All right, in this presentation, we are going to just review the main things you're going to need to know for our weather test next Thursday. And you can see on the screen here, there's three main topics. We're going to talk very briefly about the winds, then we're going to look at air pressure and fronts, and then finally severe weather. If you are able to and want to print off that study guide, that might be a good idea to have in front of you. If you'd rather, if you can't print that off, you can just write it on a piece of paper, and you may want to have that in front of you. Again, you can always go back to this when you get ready to do the study guide, but I think it will help you in doing the study guide. All right, so the first thing we're going to look at is wind. And the definition of wind is any movement of air due to differences in air pressure. And the reason those differences happen in air pressure is because of the uneven heating of the earth. And what we mean by that is because the earth is round, when the sun, which is these red lines here, when the sun shines on the earth, it doesn't shine on every place exactly the same. So what I want you to look at here, see here where it says small area. Notice that this is at the equator. So you know the equator is hot. And the reason it's hot is because when the sun is shining on it, it is directly hitting that equator head on. Like imagine if you had a heater pointed straight at you, you would get all the heat from that heater. But look what's happening up here where it says large area, okay? You know that this area up here is the North Pole. You obviously know it's cold. Well, the reason it's cold is because the sun does still shine there, but because it's at the top of the earth where it's really, really curved, the heat from the sun gets spread out over a larger area. So it's not getting the direct heat of the sun like the equator does. It's still getting heat, but because it's so spread out over a larger area, it lessens the intensity of it. Now there's two kinds of winds. The first kind is what we call global winds. And one thing I want you to see here is that you can kind of see the word globe in global. So that's what I want you to think about. Global winds blow in one direction. So for example, the westerlies here, look, they always blow from the west. The easterlies always blow from the east. Those never change, okay? Global winds always blow from the same direction. They also blow over much longer distances, okay? They are going to go over hundreds of miles. They're also constant. So these are winds that are always blowing no matter what the weather is doing. And one thing I want you to note, you see how all of these arrows are curved? I want you to think of the ocean currents that we talked about earlier in the year. What is it that makes all of the ocean currents, and in this case the wind currents, curve? It's the Coriolis effect. Remember, the Coriolis effect is the spinning of the earth that makes wind and water currents curve. The next kind of winds are much smaller. These are called local winds. And so these winds can blow from any direction. So for example, in the picture here we see sometimes they blow this way, but sometimes they blow that way. Sometimes they blow down, sometimes they blow up. So they can go in any direction. They also happen over much shorter distances. So for example, let's see in this bottom picture here, this is just going a few feet from the land onto the ocean. So we're not talking hundreds of miles here. We're talking very, very short distances, and it usually has to do with the geography of the land. So for example, these winds here on the left side of your screen are land and sea breezes. They happen on the coast. So would we get any land and sea breezes here in Johns Creek? No, of course not, because there's no ocean here in Johns Creek. So it's only going to affect very small places. On this side of the screen here, we have our mountain and valley breezes. So again, we are not really going to have mountain and valley breezes because there's no big mountains here in Johns Creek. All right, so let's talk about air pressure now. Air pressure is the measure of the force with which air molecules push on the surface. So we know pressure is always happening. It's just hard with air because we can't see it. But that pressure creates different kinds of weather. So I want you to look at this picture here, and I think it's a really good example of what kind of weather goes with each pressure system. So this big blue capital H here stands for high pressure. The red L over here stands for low pressure. You'll hear weathermen talk about high and low pressure a lot. You'll also see these H's and L's a lot on weather maps. So here's how I want you to remember them. High pressure means that you've got heavy cold air pushing down. That's why this H is blue, because it's cooler air. On the other hand, low pressure is warmer air that rises. So that's why the L is red, because it's warmer air, and warm air is less dense, so that's why it rises. Now I want to show you a little trick to remember what kind of weather goes with with each pressure. So in high pressure, we have cool sinking air, and as you can see by our picture, what that means is we usually have clear weather. Usually high pressure makes you, not very good with writing this, happy. Because usually in high pressure, you're not going to have any rain. It's not going to be very cloudy. This is good weather. Clear weather. It makes you happy, high pressure. On the other hand, you can see over here in our low pressure, we've got some rain. So I want you to think of that L is lousy weather. Because usually with low pressure, that warm air rising is going to create clouds, which typically is going to produce rain. So high pressure makes you happy because it's clear weather. Low pressure is warm air rising, usually rain, and it's going to be lousy. All right, all this moving air is basically air masses. So what is an air mass? An air mass is just a large body of air where the temperature and moisture content are similar throughout. So what that means is in a single air mass, if it is warm, that means that the whole air mass is warm. You can't have an air mass that's like part warm and part cold. It doesn't happen that way. They can't be that way. So if it's a warm air mass, the whole air mass is warm. Now it could be warm, but maybe it's dry. Maybe it's coming over land and it's a dry air mass, so warm and dry. It could be warm, but if it's coming over the ocean, that means it's going to be moist. It's going to be humid and have water in it. But regardless, whatever the temperature is going to be the same throughout. Whatever the moisture is the same throughout. You can't have an air mass that's like half dry and half humid. It doesn't work that way. Now, when all those air masses meet, that's what creates our different kinds of weather. So in this picture here, what we see are many different kinds of air masses. So here we are, if I had to guess, right about here is where we are, okay? So what that means is this big red blob, don't worry about maritime tropical. You don't have to know the names of these air masses, but what I want to point out is their temperature and their moisture content. So this big one down here, this big red one, is the one that affects us most in Georgia. It's warm because look where it's coming from. It's coming from down here near the equator, and it's humid because look what's underneath it, ocean. Same thing over here at this one, right? It's warm because again, it's coming up from the equator, and it's humid because look what's underneath it, ocean. Now, if we look at these guys up here, they're going to look a little different, okay? So let's look at this blue one right here. Well, it's cool because look, it's up here coming down from the North Pole. However, it's humid because look what's underneath it, ocean. Now, this one here in the middle, it's also coming from the North Pole, so that's why it's cold, but it's dry because, yeah, there is some ocean, but it's mostly land that it's coming over. Okay, so that's why it's a dry air mass. This guy over here, also coming from the north, That's why it's cool and it's humid, because again, it's over an ocean, okay? So typically, whatever's under the air mass is going to define what kind of air mass it is. If it's coming from over the ocean, it's usually going to be humid. If it's coming over land, it's usually going to be dry. Now here's the problem. When all those air masses are moving around, they bump into each other. And when they bump into each other, it makes a front. And a front is just the boundary between the two air masses. And the way that got its name is from a battlefront. Think about in war times when two sides would go to battle, right? They would come together, and as they fought, the most fighting happened right where the two sides met each other. We call that the front lines or the battle front. That's where all the action is. And the weather is pretty much the same way. The air masses don't mix. They can't dissolve into each other because they have different densities, right? Remember on the screen before, some had water in them, some did not. Some were hot, some were cold. When they have different densities, they can't mix. It's like oil and water. Have you ever put oil and water in the same container and shake them up and try to mix them? They'll never mix because they have different densities. Air masses are the same way. Air masses cannot mix, but when they bump into each other, it makes a front. All right, now we're going to look at three kinds of fronts. The first one here on your screen is a cold front. So here's the description of a cold front. The cold air moves under the warm air and it pushes the warm air up. Now, here's what I want you to look at. In this picture, here's the cold air moving into the area, okay? So this whole thing right here, I want you to think of it as one of those air masses we just saw on the couple of screens ago. And I want you to think of cold air as like a big bully. Cold air is dense, it's heavy, and it's strong. And here's the cold air, being the big bully that it is. It comes in and it sees this warm air mass. And I want you to think of warm air as kind of wimpy. It's not very strong, it's not very heavy. So when the cold air comes in, it sees that warm air mass, and guess what it does? It's so strong, it just pushes that warm air straight up. It's almost like it lifts it up over its head and just pushes it up into the atmosphere to get rid of it. Well, when that happens, when that warm air rises, it condenses and makes clouds. And when you've got a lot of clouds, you've got a lot of chance for precipitation. And the weather that goes along with a cold front is usually going to be thunderstorms, or if it's not a full-blown thunderstorm, you're going to have some heavy rain, and if it's cold enough, you could even have snow. But I want you to think of thunderstorms as what goes with a cold front. Now, all these fronts have different symbols to them. So when you see this symbol here, these blue triangles, that means it's a cold front. All right, our next front is a warm front. So a warm front is when the warm air moves over the cold air. So let's see what that looks like. All right, so we're going to use our same masses again. This time, it's the warm air coming in first. And remember, think of that warm air as being wimpy. So here's the wimpy warm air, and he comes into the area. Uh-oh, guess what he sees? There's the big, bad cold air bully. Remember, that cold air is heavy and dense. That wimpy warm air can't move it out of the way. It's not strong enough to lift it up like the cold air is. So he pushes against it as hard as he can, but really all he's doing is just kind of going over top of it. And so this doesn't create those big, tall thunderstorm clouds. It does make clouds, and you are going to have some rain, but it's more of like a drizzly rain. You're not going to really have major, heavy downpours like you do in a cold front. Now, the symbol that goes with a warm front are these red semicircles. All right, the last kind of front is a stationary front. So here's our definition. The warm air meets the cold air, and they stop moving. So in this case, the cold air comes in, and maybe it's kind of a weaker cold air mass. You know, all cold air masses aren't exactly the same exact strength. Same thing with a warm air mass. Not all warm air masses are the exact same strength. So in some cases, you may have a weaker cold air mass and a stronger warm air mass, and here they are pushing up against each other, and guess what? Neither can move each other out of the way. Here's something else I want you to think of. This word here, stationary. Do you know what a stationary bike is? You might have one in your house, or you've seen one at the gym. Stationary bikes are bicycles, but they don't go anywhere. They stop, they stay still. So you can pedal as fast as you can, but you're not going to go anywhere. Well, that's what's happening in the stationary front. They're pushing up against each other, but nobody's moving. So you know what kind of weather that brings? Many days of cloudy, unchanging weather. So it's just going to be cloudy for many days. And that's the key here. That's what I want you to focus on with stationary front. Many days. In cold fronts and warm fronts, sometimes they can move in within a few hours, but not the stationary front, because remember what's happening? They've stopped moving. So that's why it's going to take longer, and you're going to have many days of that kind of weather. Now, this symbol, you'll notice, is kind of a combination of the two. You've got the blue triangles on one side and the red semicircles on another. All right, let's get into our storms now. So the first one we're going to look at is a thunderstorm. Okay, here's what you need to know. Thunderstorms happen in low pressure areas. Remember, low pressure is lousy. That's that warm air rising. Usually it's brought on by cold fronts. So here's the steps. What you've got is you've got warm air rising, okay? Well, I want you to look at this dotted line right here, okay? This is kind of where the temperature changes in the atmosphere. So up here, it's really pretty cold up there. So when that warm air rises up, we know that it's going to condense and form clouds. And so what happens is that warm air keeps rising and it keeps condensing, and that's where you get these big, tall thunderstorm clouds from. Well, as that cloud gets bigger and bigger, guess what's going to happen? Eventually, it's going to start raining big time. And then it can also produce some thunder. And then eventually, that cold kind of overtakes. And when you don't have that big temperature difference of warm and cold air, it kind of fizzles out. So that's how thunderstorms fizzle out, is eventually that cooler air overtakes it. All right, let's talk about tornadoes. Believe it or not, tornadoes actually start out as just a thunderstorm. There's one big difference that turns a thunderstorm into a tornado. Can you guess what it is? That's right, you see it right here. It's these rotating and spinning winds. So when those winds and those clouds start spinning and rotating, that's where you get your thunderstorms from. Or excuse me, your tornadoes from. All right, the other big storm is the hurricane. Hurricanes start out, look at this, as a band of thunderstorms. So several thunderstorms come together, and you also have big rotation happening. All those thunderstorms kind of start revolving around each other and combining together. So let's look at the two side by side and kind of do a comparison here. Hurricanes form on the water. Tornadoes form on the land. Hurricanes tend to be large. Some of them can be hundreds of miles wide. You can see them from space on satellites. Tornadoes, however, are smaller. Now, that doesn't mean they're not dangerous and powerful. They can still pack a punch, but compared to a hurricane, they are much smaller. Typically with a hurricane, you've got some warning. Because hurricanes are so big, it can take them days to form. And many times you know days in advance that a hurricane is headed your way, so you've got time to evacuate. You don't have much time in a tornado. And so that's why it's important to pay attention to weather warnings to make sure if one is coming in your area. They can pop up really quick, and they can kind of jump around to different places. So you don't have much time to evacuate or head for safety in the case of a tornado. Now they do have some similarities. They both happen because of low pressure. Remember, low pressure is lousy weather. And I think we can agree that being in a tornado or a hurricane is pretty lousy. Obviously, they both have very high wind speeds. Believe it or not, sometimes a tornado can have higher wind speeds than a hurricane. So they're both very dangerous, and that's our last point here. They're both extremely dangerous. One is not worse than the other. So it's important that you know what to do in the case of those storms. So what do you do? Well, you need to pay attention to the weather, whether it be a weather app or watch the news. Here are the 3 things you need to know about. The first is what we call an advisory. This means that, you know what, conditions are not really serious, but it could cause some inconvenience. Maybe you've got plans to have a picnic outside and it's going to rain. That might be a weather advisory. A watch means that the weather conditions are possible and you need to have a plan. So it means that, you know what, there is a lot of rain, there is a lot of wind. This could turn into a strong thunderstorm. It hasn't happened yet, but just in case, have a plan of what you're going to do. Do you know where your safety shelter is? Do you know what to do if it were to turn into a tornado? Just have a plan. Now, the weather warning is the worst. This means that the severe weather is there. It means that the conditions that pose a threat to life and property are actually happening. For example, it means they've seen a tornado. It's touched down. You need to take cover. You're in the path. Think of it this way. Here's the way I like to think of it. Baking a cake. Who doesn't love a cake, right? A weather watch means that you've got all the ingredients for a cake. Maybe you've got your butter, your flour, your eggs, your sugar, all sitting on the counter, right? Same thing with a weather watch. You've got wind, you've got rain, maybe you've got some thunder, maybe some lightning. Everything is there, but it hasn't formed into a storm yet. It hasn't formed into a tornado or a hurricane. But a warning means that it's all put together. You've made the cake, it's there. So in the case of let's say a tornado warning or hurricane warning, it means they've seen it. It's touched down. It's on the way. Be safe.